Good night, everybody. Well, it's night right now. I'm not sure when you are watching this, but I'm going to go over part of 6.2, the first part of 6.2, which is adding and subtracting a constant from a random variable. So this was the day that a lot of you guys went to IHOP for. So I know you guys might not have seen the video, but I'm going to go over how to add and subtract constants to and from variables, and how we can find expected values and standard deviations from that. So we're going to start off with our first problem, which is subtracting 2 from x, and we are going to want to find the expected value of the expected value of x minus 2. That's what this x minus 2 represents. And then the standard deviation of x minus 2. So these symbols symbolize the expected value and standard deviation of x minus 2. So first of all, this is like what you guys learned with data distributions, but as a visual, let's consider a distribution. In this case, our e of x normally is just 3, and our standard deviation of x is 4. So if we just draw like a little diagram, and we will mark this as 3, that's our center. We know that there's 3 standard deviations. Almost the entire distribution is within 3 standard deviations of the mean. So we'll keep this standard deviation at, this will be 7, 11, and 15, and going this way we'll have -1, -5, and -9. I want to make sure you guys can still see that. So in this case we have distribution. We're just going to make it look normal, and we're not sure if it's normal or not, but we'll make it look normal for simplicity's sake. So we have a distribution. This is our regular x distribution. It's centered on 3, and it has standard deviation of 4 right here, and then most of it falls within 3 standard deviations of the mean. So if we consider, if we're subtracting 2 from x, this is going to cause our distribution to slide down. We're going to move it this way, and so if we do that, we get a distribution that is centered on 1. If we're going to move it, we're going to subtract 2 from x, so our standard deviation, or our expected value, is 1 now. But we just slid it over, so we're just going to move the whole thing over. So I don't even think I need to draw that again. So we're just going to slide this over 2 slots each, so we get a distribution that kind of looks like this now. Here the distribution, the second distribution, is on 13 and now -11. So you can see that now our distribution is centered at 1 here. So this is the first mean, and this is, well, it doesn't really look like it, but our new standard deviation, or our new expected value, is 1. So we can write that down. It would do exactly what we expect. So we have e of x minus 2 is just 1, because we slid the entire distribution over to the left on the number line. So our center moved from 3 to 1. This can also be found mathematically by doing e of x minus 2 is just equal to e of x. We can pull out the 2. So we get e of x minus 2, which we have up there, is equal to 3 minus 2, which is just 1. Okay, now our standard deviation. If you look at these diagrams, you'll notice for the first one, it ranges, for our first distribution, we can just ignore this, this is irrelevant. For our first distribution, it ranges from -9 to 15. So it ranges from -9 to 15. That's our first distribution. We'll write 1. Our second distribution, since we slid everything down 2, now ranges from -11 to 13. you'll notice if you do some math that there's 24, there's 15 minus -9 is 24, so the range of most of this distribution, the range is 24. Since we slid our distribution down, we can take a look at what this range is, and we find again that the range of our second distribution slid down, our x minus 2, is also 24. Since we haven't changed how wide or how compact the distribution has become, our range or our standard deviation has not increased or decreased. So we can just say that the standard deviation of x minus 2 is exactly the same as it was for just regular x. So we write that. Standard deviation of x minus 2 is equal to standard deviation of x, which if we look up there is just equal to 4. So when we add, or well, in this case, when we subtract a constant, we do not change its standard deviation. Its standard deviation does not change because it's only being slid up and down the number line. It's not being spread out anymore. So yeah, that's what we'll do for this one, and I will make another video for adding momentarily.